Computer software. The term software refers to the collection of data, instructions, and programs that provide a computer or other electronic device the ability to carry out particular operations or functions. It is the exact opposite of hardware, which refers to a computer's external components. We can compare the software with our soul because it brings life to the computer. Without software, computer machine is just like a dead body, which cannot perform any activities. Common types of computer software are listed below. System software. This includes the operating system, device drivers, and utility programs that enable the computer's hardware to function properly. Application software. These are programs designed for specific tasks, like word processors, spreadsheets, games, and web browsers. Middleware. Middleware is software that acts as an intermediary between different software applications, facilitating communication and data exchange. Firmware. Firmware is software embedded in hardware devices, like the software in a digital camera or the BIOS of a computer. System software. The system software is a collection of programs designed to operate, control, and extend the processing capabilities of the computer. System software is generally prepared by computer manufacturers. The programs in this software are written in low-level language. So much software can interact with the hardware at a very basic level. System software serves as the interface between hardware and end users. Examples of system software are macOS, Linux, Android, etc. System software is classified into three types. An operating system, language and translators in. Utility software. Operating system. An operating system, OS, is a system of software that manages computer hardware and software resources and provides common services for computer programs. It acts as an interface between the user and hardware, i.e., on one side, it makes the hardware user-friendly, and on the other side, it manages access to memory, I/O devices, processor units, and data or information. The general goal of OS is to operate the computer with a minimum of idle time and execute the user programs in the most efficient and economical way. It also forms the basis on which application software is developed. Some of the popular operating systems are MS-DOS, Microsoft Windows, Linux, and Mac OS. Language processors and translators. A language processor, also known as a translator, is a computer program that converts source code from one programming language to another. The purpose of a language processor is to make computer programs written in high-level programming languages understandable by the computer. There are three types of language processors: assembler, compiler, and interpreter. An assembler translates a program written in assembly language into machine code. A compiler reads the complete source program written in high-level language as a whole in one go and translates it into an object program or object code. An interpreter translates a program written in a high-level language into machine code, one line at a time. The translator detects and identifies errors during translation. Utility software. Utility software is a type of software that is designed to help users manage, maintain, and optimize their computer systems. It includes a wide range of tools and applications that perform specific tasks to improve the performance, security, and functionality of a computer system. Utility software provides a range of tools and applications that help users manage and maintain their computer systems, optimize their system performance, remove unnecessary files and programs, and keep their systems running smoothly. It also includes tools such as antivirus and encryption software that help users protect their computer systems from security threats such as viruses, malware, and unauthorized access. Examples are disk defragmenters, system profilers, network managers, application launchers, antivirus software, backup software, disk repair, etc. Application software. Application software is a set of programs that is being developed to carry out operations for specific applications. It can process text, numbers, graphics, or a combination of these. Some application software needs to be used within the particular operating system. It helps the user to work faster, more efficiently, and more productively. Software for word processing, spreadsheets, presentations, graphics, CAD, CAM, emailing, etc. are some examples of application software. The application software is also classified into two categories: packaged software and tailored software. Packaged software. Packaged software is a generalized set of programs designed and developed for general purposes. They are ready-made software that can perform tasks like preparing documents, keeping accounts, maintaining databases, playing audio and video files, editing images or videos, etc. Packaged software is difficult to modify or alter. It can be installed quickly and easily. Example: Microsoft Office. Tailored or customized software. It is software developed according to the needs of a particular user or organization. Custom software can be designed with specific security features to protect sensitive data while meeting compliance and regulatory requirements. Tailored software can be altered as needed and can be designed to be user-friendly. It is more expensive than packaged software but offers greater flexibility and control. In Nepal, there are some software companies like Mercantile Communication Private Limited, Nepal, Nepalsoft Solutions Private Limited, Crystal Solution Private Limited, Leading Edge Software Private Limited, etc. Utility software. Utility software performs day-to-day tasks related to the maintenance of the computer system. It is used to support, improve, expand, and secure existing programs and data in the computer system. Certain utility software comes along with the operating system. Some utility software is available for free as per requirements, and some of the utilities are to be purchased from the market. Some of the tasks commonly performed by utility software include formatting hard disks and pen drives, taking backups of files, data recovery, virus protection, etc. Web-based software. Software that operates on a server and is accessed through a web browser while connected to the internet is referred to as web-based software, sometimes known as cloud-based software. Users may access it from any place with an internet connection because it doesn't need to be downloaded or purchased and doesn't require any software or devices. Webmail, social networking sites, online stores, and office applications are some examples of web-based software. Mobile application. A mobile application, sometimes known as an app, is an application of software made specifically to operate on a mobile device, like a phone, tablet, or watch. Mobile applications are built to operate on certain mobile operating systems like iOS, Android, and Windows Phone and are created expressly for use on tiny, portable computing devices like smartphones and tablets. Mobile applications may be used for a wide range of things, such as general productivity, information retrieval, social networking, email, calendars, contacts, banking, online shopping, planning trips, and getting the latest news and weather reports. Mobile applications usually fall into three basic categories. Native. A mobile app that runs only on the specific hardware for which it is designed. Web-based. A mobile app that makes use of the Internet's connectivity to provide some or all of its functionality. Hybrid. A combination of native and web-based apps. Advantages of mobile applications. Convenience. Mobile apps are easy to use and accessible on the go, providing users with quick access to information and services. Better user experience. Mobile apps offer a better user experience than mobile websites, as they are designed specifically for mobile devices and can leverage the device's hardware and software capabilities. Data capture. Mobile apps can gather valuable data about user activity and buying habits, which can be used to improve the app and the business. Communication. Mobile apps make it easier to interact with customers and prospects, including the ability to send push notifications to attract their attention and prompt action. Branding. Mobile apps can help businesses build their brand and increase customer loyalty. Disadvantages of mobile applications. Difficulty to create. Developing a mobile app can be challenging and requires specialized skills and knowledge. Cost. Creating a mobile app can be expensive, especially if it needs to be developed for multiple platforms. Updating. Mobile apps require regular updates to stay compatible with the latest platform revisions, which can be time-consuming and costly. Availability. Not everyone can use mobile apps, as they require a compatible device and operating system. Need for support. Mobile apps require ongoing support to ensure they continue to function properly and meet user needs. Middleware software. A form of software called middleware enables developers and operators to more quickly create and deploy applications by offering common services and capabilities to applications. Middleware can refer to a broad variety of contemporary software components and has been a part of the vocabulary of software engineering since the late 1960s. Application runtimes, business application integration, and numerous cloud services are all examples of middleware. Web servers, single sign-on, SSO, communications, and in-memory caching are some typical tasks that middleware can do. Firmware software. A particular type of computer software called firmware offers low-level control for a device's particular hardware. It is software that is stored in the non-volatile memory of hardware. Basic machine instructions are provided by firmware, enabling hardware to run and interact with other programs running on a device. Software for hardware is a common term used to describe it. Hardware devices have firmware built into their memory to help with efficient operation. It offers guidance to assist hardware with initialization, connectivity, and fundamental input-output operations. Personal computers, peripherals including graphics and video cards, cameras, mobile phones, network cards, optical drives, printers, routers, scanners, and television remote controls are some examples of devices where firmware is used in the real world. Operating system. A computer's operating system, OS, is a type of system software that controls how computer hardware and software resources are used and offers a number of services to programs. It serves as a bridge between the hardware and software, enabling users and programs to interface with the computer's hardware in a consistent and structured way. The two primary objectives of an operating system are listed below. Making a computer system convenient to use. Managing the resources of the computer system. Functions of an operating system. I/O management. Command interpreter. Data management. Memory management. Process management. Device management. File management. Time sharing. Security management. Deadlock prevention. Interrupt handling. Virtual storage. Functions of an operating system. The major functions of an operating system are listed below. I/O management. Input-output management is essential to the operation of any computer. It allows the computer to interact with and control access to peripheral devices such as a keyboard, mouse, terminal, like the modem and NEC cards, disk, monitor, and printer. Command interpreter. Every OS must provide a command interpreter for its operation. It can have direct access to the functions of the operating system. The command interpreter reads and executes the commands that a user types at a terminal or keyboard, interprets them, and translates them into a detailed set of instructions that the computer hardware can understand. Data management. The data management functions of an OS govern the input and output of data and their location, storage, and retrieval. It is also responsible for storing and retrieving information on disk drives and for organizing that information on the drive. Memory management. The operating system manages the main memory. Main memory is made up of a large collection of words or bytes, where each word or byte is assigned a certain memory address. Main memory can be accessed directly by the CPU. For a program to execute, it should first be loaded into the main memory. When the user requests a CPU read/write operation, the OS determines the amount of required memory to load the program and data into RAM, or main memory. Process management. Process management allocates a processor to execute a chosen process. It finds the status of processors and processes, traffic controller, chooses a job scheduler, chooses the process in the job, process scheduler, allocates the processor to the process, dispatcher, and frees the processor when the process is executed. Device management. Device management allocates a device to a process. It finds the status of the device, channels, and control units, finds answers to questions like which process allocates the device to the process, I/O scheduling, initiates the IP operation, and finally frees the device when the process is completed. File management. Creating, editing, organizing, and managing files on a computer's storage devices are all examples of file management, which is the act of manipulating files in an operating system. The operating system's file system has the ability to manage both single files and groups of files that are present on a computer system. The file management system offers a logical and effective method of classifying files and folders so that users can find and access them with ease. Time sharing. A time-sharing operating system, also known as a time-sharing system, or multitasking operating system, is a kind of operating system that enables multiple users to interact with the system at once in order to maximize the utilization of a computer's resources, particularly the central processing unit, CPU. To effectively share a single computer among several users, time-sharing systems were created. Security management. The security feature protects one user from another and the OS as a whole from all users. Its main function is to make sure that only authorized users get access to the computer and its data, and the users only do things they are authorized to do. A larger OS provides some kind of security, but the degree varies from one OS to another. Deadlock prevention. Deadlock is another function of an OS. During processing, a situation can arise in which a resource, hardware or software, shared by two or more processes cannot continue because the resource required by one process is held by another. This situation is known as a deadlock. Think about an office where computer A, computer B, and computer C all have access to the same printer. Only one print job may be handled by the printer at once. While each computer has the ability to deliver prints to the printer, doing so requires having exclusive access to it. In this case, the print jobs on all three PCs are stuck and cannot be completed. This is an example of a deadlock involving a printer and multiple computers. If the deadlock cannot be avoided, the OS detects it and attempts to recover from it. Interrupt handling. An essential component of an operating system, OS, is interrupt management, which enables the OS to react to hardware and software events that demand quick attention or action. Signals called interrupts are produced by hardware or software to stop the normal process of CPU operation and call the OS's attention. Virtual storage. In the context of operating systems, the term virtual storage often refers to a method of managing and allocating memory resources that maximizes the usage of physical memory while giving the appearance of having more memory than is really present in a computer. Modern operating systems employ virtual memory systems, which are frequently connected to this technology. Role of the operating system. The operating system, OS, manages the resources of a computer system and provides a platform for users to run applications quickly and effectively. Some of the key roles of the operating system are listed below. Resource management. The operating system controls the computer's resources, including the CPU, memory, disk drives, and printers. It distributes resources among several programs and makes certain that each receives what it requires. Input-output management. Keyboards, mice, and printers are examples of input-output I/O devices that are managed by the operating system. It keeps track of which device is plugged into each port and controls how the devices and computer communicate. Process management. The operating system controls the computer's operations, including scheduling, synchronization, and inter-process communication. Memory management. Each application is given the memory it requires to function thanks to the operating system's memory management. File management. File management refers to how files are created, modified, arranged, and controlled on a computer's storage devices by the operating system. Security management. Security measures are provided by the operating system to guarantee that each user's data is shielded from other users. Operating system terminology. OS are divided into different types depending on their properties. Some of them are listed below. Classification of OS based on processing. Multiprogramming OS. A multiprogramming operating system may execute several applications on a machine with a single CPU. In a multiprogramming operating system, the other program is ready to use the CPU if one program has to wait for an input-output transfer. As a result, many tasks may share CPU time. It's not necessary for them to perform their tasks simultaneously, though. Resource management is the major goal of multiprogramming. The major components of a multiprogramming system are the file system, command processor, transitory area, and I/O control system. Multitasking OS. A multitasking operating system is designed to allow multiple tasks or processes to run concurrently on a single computer, providing the illusion of simultaneous execution. Multitasking is a fundamental feature of modern operating systems, and it enables users to run multiple applications and perform multiple tasks at the same time. Multiprocessing OS. A multiprocessing system has more than one processor linked together in a coordinated way. The multiprocessing OS is one that supports running a program on more than one central processing unit, CPU. Server systems and superservers are specially designed to support multiple processors. MVS and Unix are the two commonly used multiprocessing OS. Distributed OS. It is a model where distributed applications are running on multiple computers linked by communications. A distributed OS is an extension of the network operating system that supports higher levels of communication and integration of machines on the network. These systems are easily scalable, as many systems can be easily added to the network. Network OS. An operating system known as a network operating system, NOS, is one that has been created particularly to control and help network communication and resource allocation within a computer network. In contexts where numerous computers are connected and need to share resources, such as files, printers, and data, and cooperate on tasks, network operating systems are frequently used. Time-sharing system. A time-shared operating system gives each user access to a tiny section of a shared machine at once using CPU scheduling and multiprogramming. At least one unique application is stored in memory for each user. A program is loaded into memory and runs for a brief length of time, either to finish I/O or before completion. Time slice, time slot, or quantum are all terms used to describe this little window of time when the CPU is focused on the user. Multithreading OS. A program in execution process can be divided into multiple smaller sub-processes. These sub-processes are known as threads. A multithreading OS has the ability to divide the process into threads and execute them concurrently. Threads are individual processes that execute simultaneously in a multitasking OS. The programmer must carefully design the program in such a way that all the threads can run at the same time without interfering with each other. Batch processing OS. An operating system that processes data in batches, gathering a set of related tasks and processing them all at once, is known as a batch processing operating system. Tasks are often carried out in a batch processing system without direct user input and frequently with little human involvement. This kind of technology is often used for operations that don't require direct human engagement, such as automating repetitive processes, processing massive amounts of data, and executing background jobs. Online processing OS. In the online processing methods, transactions are processed as soon as they happen and at the place of origin. It is quite simple compared to real-time processing. In this type of processing OS, Users can interact or provide inputs during processing as well. The output is provided back to the users as soon as the processing is completed. It is a popular processing technique at present. Real-time OS. A real-time operating system is a computer operating system designed to handle events as they occur. It is commonly found and used in robotics, cameras, complex multimedia animation systems, and communication, and has various military and government uses. To make sure that real-time processes have the resources they require when they require them, RTOSs include techniques for controlling system resources, such as CPU time, memory, and I/O devices. Classification of OS based on user interface. We know that OS is the common place where the user and system communicate with each other. The user interacts with the OS by using two types of interfaces. These are the character, command user interface, called GUI, and the graphic elements interface, called graphical user interface, GUI. Command, character user interface, GUI. The character user interface is referred to as GUI. It is a user interface in which all communication between the user and the computer takes place via the keyboard, and all actions are controlled by commands. The majority of the early computers used GUI, which is the GUI's predecessor. A user has to learn many commands for proper operation of the computer system, so instead of CUI, most computers utilize GUI. It operates by enabling the user to issue numerous text lines, also known as command lines, of instructions to a program. The Windows Command Prompt and MS-DOS are the two most common GUI examples. The GUI makes writing programming scripts easier, which is one of its uses. Features of CUI. The GUI is less user-friendly than the GUI. Commands are used to instruct the computer. The user needs to remember the commands for operating this system. It cannot display graphics, icons, pictures, multimedia, etc. Pointing devices like the mouse, joystick, trackball, and trackpad are not recognized. GUI-based OS is usually an 8 or 16-bit OS. It is much faster than GUI-based systems. It is a single-task and single-user OS. It can be used on low memory and low processing speed computers. Graphical User Interface, GUI. GUI stands for Graphical User Interface. The operating environment also changed. This led to the development of a graphical user interface where users can interact with computer systems using pictures and graphs rather than characters or commands. It displays the icons, buttons, dialog box, windows, scroll bar, etc., and others on the screen. The user sends the instructions and data by moving a pointer on the screen and selecting certain objects by pressing the button on the mouse. With the advancement of technology, computer systems have become quicker and cheaper. A popular GUI is Microsoft Windows. Features of GUI. The GUI interface is easy to operate and user-friendly. Users don't have to understand the syntax. The job that is to be performed can be understood by the icons present in the GUI mode. Other peripherals like a mouse, joystick, and light pen can be used. Games can be played in an easy way, i.e., an amusing environment can be created. Users can explore more by themselves. Users don't need to remember all the commands. GUI environment is full of multimedia operation and animation. It requires a larger memory space and faster processors to operate. It is capable of operating multitasking, multiprogramming, and multi-user systems. GUI-based OS are usually 32 or 64-bit OS system. Classification of OS based on the mode of the user. Single user OS. An operating system that can only be used by one person at once is referred to as a single user or single tasking operating system. In such systems, a single user is always able to utilize the computer and run programs. Single-user operating systems are typical on laptops, workstations, and personal computers because they offer a simple and welcoming environment. Multi-user OS. An operating system that supports numerous people working on a computer at once is known as a multi-user operating system. These systems are frequently used in settings like servers, mainframes, and time-sharing systems when several users must share a single machine and its resources. Concept of open source as operating system. Computer operating systems that are open source are those whose source code is made publicly accessible under an open source license. Since everyone may see, alter, and share the source code, anyone can occasionally add new code or make enhancements to the existing codebase. Transparency, teamwork, and community-driven development are the pillars on which open-source operating systems are based. Servers, embedded devices, scientific computing, and education are just a few of the areas where open-source operating systems are becoming more and more popular. They provide for vendor lock-in prevention, flexibility, and cost-effectiveness. Communities and organizations may work together, develop, and customize the operating system to meet their unique needs thanks to open source. Introduction to Linux. Based on the Linux kernel, the Linux operating system family is a collection of free and open-source Unix-like platforms. On September 17, 1991, Linus Torvalds first made it available. On the Internet, Linux is freely accessible, and users may choose from a variety of variants to suit their needs or preferences. There is a sizable community behind Linux, and it offers good stability, seldom stutters or freezes, and doesn't require a reboot after a short while. The performance of the Linux system is far higher than that of other operating systems, and it effectively manages a large number of users working simultaneously. Linux is adaptable to networks and has a great degree of flexibility. Introduction to Unix. A group of multitasking, multi-user computer operating systems known as Unix was created at Bell Labs in the middle of the 1960s. Since its original development for minicomputers, it has been ported to a number of different hardware platforms. Unix is a well-liked option for enterprise-level computing because of its reputation for dependability, security, and scalability. UNIX's fundamental design tenet is to offer straightforward, potent tools that may be used to complete difficult tasks. Instead of using a graphical user interface, GUI, it has a command-line interface that enables users to communicate with the system via a sequence of commands. Concept of mobile operating system. An operating system for mobile devices, such as smartphones, tablets, smartwatches, smart glasses, or other non-laptop personal mobile computing devices, is known as a mobile operating system. Mobile operating systems combine desktop operating system characteristics with extra features that are helpful for mobile or handheld use. Typically, these systems have a wirelessly integrated modem and SIM tray for telephony and data connectivity. Apple iOS, Google Android, Samsung, iOS, and Windows are a few of the widely used mobile operating systems. Smartphones use a variety of operating systems, including Symbian OS, iPhone OS, BlackBerry OS from RIM, Windows Mobile, Palm WebOS, and Android. The software that enables mobile devices to execute apps and other programs is known as a mobile operating system. Types of mobile operating system. There are many different kinds of mobile operating systems on the market right now, including Android OS. Built on the Linux kernel and open-source software, Android is now the most widely used mobile operating system. It was created by Google and is utilized by different smartphone producers. iOS. Apple created the iOS mobile operating system for its iPhone, iPad, and iPod Touch gadgets. It is a closed-source operating system, which means that the public cannot access the source code. BlackBerry OS. Research in Motion, RIM, currently known as BlackBerry Limited, created the exclusive mobile operating system known as BlackBerry OS. Windows Mobile OS. Designed for smartphones and pocket PCs, Windows Mobile OS is a mobile operating system from Microsoft. Symbian OS. Nokia created the Symbian OS mobile operating system. Before Android and iOS gained popularity, it was one of the most extensively used mobile operating systems. Tizen. The Linux Foundation created the open-source Tizen mobile operating system, which is backed by Samsung and other businesses. Huawei. Huawei created the mobile operating system known as Harmony OS.